Hello everyone, I'm Chenyang Zhao from University of Southern California. I'm happy to present my recent research enhanced super-selective Picasso. I have nothing to declare. SS Picasso is a variation of Picasso that allows spatially selective labeling of an individual artery. SS Picasso provides a method for the mapping of blood supply of individual arteries and the evaluation of the collateral pathway. Literature have shown its clinical values in various diseases. However, the labeling efficiency of SS Picasso is quite low. B1 field inhomogeneity at 70 makes the implementation even more challenging. Parallel transmission pTx with B1 phase shimming has been a solution to address this problem, and a previous study used uniform shimming to achieve higher labeling efficiency and uniformity for non-selective Picasso. In this study, we aim to use a region-selective B1 shimming to improve labeling efficiency and selectivity of the current SS Picasso. The algorithm of the region-selective B1 phase shimming was designed to simultaneously improve B1 in a labeled artery and suppress B1 in unlabeled arteries. We labeled BA and 2SAA in two different planes. For BA, we can achieve 10% B1 increase. For one side of ICA, we can achieve 70% increase for the labeled ICA and 50% decrease for the unlabeled ICA and BA. Same for the other side of ICA. A simulation study of SS Picasso was designed with varying B1 scaling factors. A phantom experiment was also designed to test our method. We obtained reasonable TOF, B1 maps, and Picasso images with this phantom. In the in-vivo experiment, our scanning protocol includes TOF, B1 maps, non-selective Picasso, SS Picasso, and enhanced SS Picasso. We chose the SSG max as 5 millitesla per meter according to our simulation, and the simulated profile of labeling efficiency versus distances from targeted position was given on the right. The simulation shows that our shimming method can improve labeling efficiency by 50% compared to CP shimming for the distances within the labeled vessel. Also, by reducing B1, our shimming method can reduce mislabeling effect at unlabeled positions by 50% compared to CP shimming. In this phantom experiment, I moved the SS labeling target from the left tube to the right tube and measured the subtracted signals on left and right side. Blue bar indicates signal measured from left side, and the red bar is for right. So moving from position 1 to position 6, you can see the blue bar decreases while the red bar increases. With a greater grading strength, for example Gmax at 7, you can see a better separation of blue and the red bars. Comparing region-selective shimming to CP shimming, we can get a generally higher labeling efficiency, and the overlapping bars in the case with Gmax at 3 were actually reduced. This demonstrates a better selectivity. This is the first subject. Comparing to SS Picasso, enhanced SS Picasso gives a brighter left and right perfusion maps, and this is indicated by the bar plots. When red SAA is labeled, the red perfusion is almost doubled, and for left and posterior, a negative mislabeling effect became values more close to 0. This is the same for labeling the left SAA. When we label BA, although the effect is not as significant as SAAs, we can still observe a slight increase in posterior and decrease in left and right. This is our second subject. SS Picasso is again clearly enhanced by our method, and this time we can observe the positive mislabeling, which was reduced by our method. Here are the color-coded maps of the two subjects. A stronger visualization and separation of the territorial perfusion mapping can be observed. In conclusion, we proposed an enhanced SS Picasso with region-selective B1 phase shimming. Region-selective B1 shimming leads to increased B1 field in labeled artery and decreased B1 field in unlabeled arteries, which improve the labeling efficiency and selectivity of SS Picasso by 50%. Thank you for your attention.